Welcome to The Explainer. You hear about artificial intelligence, or AI, pretty much everywhere these days. It's in our phones, it's in our cars, it's changing the world. But have you ever stopped to wonder, what does it actually mean for a machine to think? Well, today, we're going to pull back the curtain and take a look inside the machine's mind.
Right, this is the big one. How does it work? We're going to go way beyond the buzzwords and really get into the nuts and bolts of how a system can look at a problem, figure out its options, and then make a choice. So let's start at the very beginning.
Before we can get into the how, we really need to get on the same page about the what. What are we actually talking about when we say artificial intelligence?
When you boil it all down, the goal of AI is pretty straightforward. It's about building machines that can do things that would normally require a human brain. You know, stuff like recognizing your face to unlock your phone, understanding what you're asking your smart speaker, or even solving really tricky logical puzzles.
And this isn't some far-off futuristic dream. It's already woven deep into our everyday lives. Think about it. When Google Maps somehow knows there's a traffic jam ahead and finds you a quicker route, that's AI. When a program can scan an X-ray and spot a tiny detail a human doctor might have missed, that's AI too. It's here, right now, working behind the scenes. Okay, this is where it starts to get really interesting. When an AI is given a problem, say finding the best move in a chess game, it doesn't just have one way of solving it. It actually has two fundamentally different strategies it can use, two different ways of thinking. And this right here is the core dilemma. It's kind of like the classic story of the tortoise and the hare. On one side, you have the heuristic approach, which is the hare. It's all about finding a pretty good answer fast. On the other side, you've got the solution guaranteed approach. That's the tortoise. It will find the absolute 100% perfect answer, even if it takes a really, really long time. So a heuristic is just a fancy word for a shortcut or a rule of thumb. Let's say you're trying to navigate a new city. You don't sit down and calculate every single possible route, right? Of course not. Your heuristic might be something simple like, I'll just follow the biggest roads heading downtown. It might not be the absolute fastest route, but it's a good, practical strategy that'll get you there without much fuss. For an AI, that kind of speed is absolutely vital for making decisions in real time. Now, check out this table because it really lays out the trade-offs perfectly. Look at the speed column. Heuristics are fast, sometimes almost instant. The solution guaranteed approach, it can be incredibly slow. But then you look at solution quality. The heuristic gives you a good enough answer, an approximation. The other one, it gives you the perfect, optimal, mathematically proven best answer. So that last column, use cases, makes total sense. For your GPS, you want a heuristic. A fast, good route is way better than a perfect route that takes 10 minutes just to calculate. But for something like online security, yeah, you're going to want that guaranteed perfect solution every single time.
So to make all these decisions, an AI has a whole set of tools it can use, a problem-solving toolkit that helps it act intelligently. Let's break down what's actually inside that toolkit. These are basically the four pillars. You've got automated reasoning, that's all about pure logic and deduction. Then visual perception, that's how an AI sees and makes sense of the world. Natural language processing, or NLP, is what lets it understand and speak our human languages. And then there's the big one, machine learning. This is what really changed the game. Instead of programmers writing out every single rule by hand, they just feed the machine tons and tons of data, and the machine learns the rules for itself. And of course, these tools don't work alone. They have to work together. This quote really nails it. A self-driving car is the perfect example. It uses visual perception to see the road, the other cars, the traffic lights. Then it uses automated reasoning to process all that info and make decisions like, okay, that light is red, therefore I must stop. It's the combination of these skills that makes something truly intelligent.
All right, if you really want to see this whole toolkit in action, there is no better place to look than video games. Seriously, games are like the perfect little laboratory for AI, a place where these ideas can be tested and perfected.
Think about it. When you're playing a game and an enemy character seems smart, like it's deciding whether to attack you or maybe run and hide, that's not just random, that's problem solving. The AI is constantly looking at the situation, looking at its goal, and calculating what it thinks is the best possible move to make.
And a really common way they do this is with something called a finite state machine. It sounds complex, but it's actually super simple. The AI character starts in a basic state, like just patrolling an area. But then a trigger happens. It sees you, the player. Instantly, it switches to the chase state. If it gets close enough, another trigger flips it into the attack state. And if you fight back and its health gets low, it switches to flee. It's a simple set of rules that makes the characters seem alive and dynamic.
But what about getting from point A to point B during that chase? That's where pathfinding algorithms come in. An algorithm called A*, that's A, then a star, is a classic, and it is a perfect example of a heuristic in action. The AI isn't calculating every single possible path through the entire map. That would take forever and crash the game. Instead, it uses that A* heuristic to make smart guesses that get it closer and closer to you, quickly finding a way around walls and obstacles. That's how it always seems to know how to find you.
Okay, and here's the kicker. All of these problem-solving ideas that were perfected in the world of video games, they didn't just stay in the game. They have incredibly powerful uses in the real world. That A* pathfinding algorithm that helps an enemy chase you through a maze, a much more advanced version of that exact same logic is what helps a self-driving car navigate a busy city, or it helps a robot in a giant warehouse find the fastest route to grab a package. The principles are exactly the same. The game world was just a proving ground.
And the impact of this is just massive. You can see it transforming almost every industry. In healthcare, AI is analyzing medical scans faster and more accurately than ever before, helping to predict diseases. In finance, it's detecting fraud in the blink of an eye. In transportation, it's optimizing everything from global shipping routes to the traffic lights in your city. And in e-commerce, well, it's behind those recommendation engines that somehow know exactly what you want to buy next. The list just goes on and on.
So let's wrap this all up. What have we learned? Well, at its core, AI is all about simulating human intelligence. To do that, it's constantly making a trade-off between speed and perfection, using things like heuristics. It relies on a powerful toolkit of logic, perception, and learning. And as we saw, the world of gaming gives us a fantastic window into how all these ideas work together to solve really complex challenges.
And this leaves us with a really fascinating question to chew on. We've seen AI master games that humans thought were unmasterable, from chess to Go. As this toolkit gets sharper and more powerful, you have to ask yourself, what are the next big, real-world games? The challenges in science, in medicine, in logistics, that AI is going to help us master next. Thanks for watching.